that one. So here is a sentence. Generally for multiplication with a sequence repetition will be done. Okay, so sequence will be repeated. Okay, a negative repetition factor gives an empty sequence. Okay, so whenever there is a negative repetition factor. So if you understand this, so what will we get as output for this one?
This is a negative one, right? So, but
Yeah.
there is already a positive 0 or something like this, right?
No, you have to again read the statement.
It's
So
a negative empty sequence.
gives an empty.
Yeah, empty sequence. So basically, it will give an empty string.
Correct. Yeah, that's the perfect answer. So like this, it will apply for anything. So if I am taking like this for this one, so like this. Okay.
Okay.
Next is true division. True division of integers, floor division of integers, and all these things.
What is true division and floor division?
Means in division we have two types.
Okay.
So one is represented with this normal division symbol, forward slash.
Okay.
And the other one is represented with this one, floor division.
Okay.
So first thing is normal case. So normal case, you consider it as a true division. I'm saying it true division because it will give the exact value.
Yeah.
Okay. So A slash B. So it will give the exact value. Okay. When we are saying floor division, it will not give the exact value for the same things. A slash B.
Okay. It's not giving floating part. Okay.
Yes, it will not give the floating part, and it will be similar to what we have read some time before. So true division of integers will yield a float. Floor division of integers results in an integer. Okay. Now we have considered actually both integers case. Okay. When any or both of the operands are floating points, then the floor division will give the result in floating point. Okay. So third case is A is equal to 5, B is equal to 2.0. Okay. And in that case, A slash B. You can see. So it will be like this. Okay. I mean, it will not give the exact value, but it will give in terms of floating point.
So basically, if the dividend is like the number which is getting divided, it's floating, so it will give in floating only.
Not really. So now I can take another one also. Above A as 5.0, B is equal to 2.
No. I mean, if it's getting divided by B, if B is floating, so then in floating only, is it?
Yes, either A or B, anything.
Okay, either A or B. Okay.
Yeah. So any one of the. So here, when any or both, condition is this.
Okay.
Any or both of the operands are floating points. So here, if both, irrespective of whether it's integer or float, it doesn't matter.
Okay.
The floor division rounds off the value and the round off occurs towards 0. This one. Ideally, it could have given 2.23 also. 5 by 2 is 2.5, but it is giving 2 because the round off will occur towards 0.
Okay.
Got it right?
Yeah.
And any division by 0, it will raise a zero division error exception.
Zero division error we saw yesterday.
Yes. So it will be, whether it is this one or this one, any kind of division, it will raise that exception.
Okay.
Next, modulo, remainder.
Yeah.
So it will give the remainder. So A percentage B. So what will be the output?
1.
Yeah. So 1, and it is in floating point because one of them is again floating point.
Okay.
And if I give, so A is equal to percentage, now it is 1. One or both are integers. So if one is floating, it will convert the other to floating, and final result is floating. So numeric operands are first converted to common type. Okay. The modulo operator always yields the result with the same sign as its second operand. So in this case, second operand is B. So for example, if I take A is equal to 5, B is equal to minus 2. Okay, then what should be the result of the remainder? So it will be the sign of the second operand. Okay, now let us take a is equal to minus 5, b is equal to 2, a percentage b. Okay, you can see the difference.
Okay.
It will always follow the second operand. Okay. So the absolute value of the result is strictly smaller than the absolute value of the second operand. So what is the absolute value? Absolute value is the magnitude. Absolute value of minus 1. So ABS is again a built-in function. It will give the absolute value of any number. So ABS of minus 1 is 1. Okay, so the result, whatever comes, that absolute value will be smaller than the absolute value of the second operand. But what is second operand? Second operand in our case is, let us take 2. Minus 2, right? Okay, minus 2. So the final result will be always less than the second operand.
Okay.
And any zero right operand will raise a
zero division error. Yeah.
Same problem. Okay. Next is exponentiation. So we have the power operator. Okay. So a star star 2. Okay. A was 5. 5 square is 25. It will give the 5 square.
5 square 25.
Yeah. Yeah. Yields its left operand raised to the power of its right operand. 5 to the power of 2. Yeah. The numeric operands are first converted to common type, and then the result is of that type. So we can mean 5.0 star 2. So it will be given in the floating value. Okay. Next, precedence. Precedence of the arithmetic operator. So now, till now we were dealing all of them individually. But if all come in one expression, then comes the precedence. Okay, within the arithmetic operators, we have this precedence. Exponentiation first, parenthesis first, exponentiation, multiplication, division, or modulo. All three have the same priority, and addition or subtraction. Okay. Whenever I am saying they have same precedence, then the order of evaluation will be from left to right.
This is same as board mass, is it? Like what we studied in maths.
Yeah, something like this. Yes. Here I am saying it's PEMDAS.
Yeah.
Okay. So
I mean,
first should be parent. Yeah. Yes, yes. Actually. 5 into 2. So we will take one something example. Minus 1 plus. So something like this. So if we are going to take this one, we have to understand how it will be evaluated. So in this case, so we will go exactly as per the order. So first is exponentiation, not parenthesis. So parenthesis will be
solve first.
10, yeah,
plus
10
plus 1.
1. So that is done. So we have to keep it like this only. 10 plus 1 like this only.
It will not solve it right now. Yeah.
Yes. Okay. 10 plus 1 and leave it, and then the last one next is the exponentiation part.
Yeah.
So 9. That will be 9. Yeah. Okay, so 10 plus 1 plus this one, and after that then we come the multiplication or division. So in that case we have to use the left to right evaluation. Okay. So anyhow we have already calculated that 10. Yeah. So 10 plus 1. So everything. No, first we have to complete the division
4
part.
Divided by 2.
Then 2. Yes. That 2. No, 4 divided by 2 is
2.
Think 4 divided by 2.
Just a second. Okay, but that is 4.
Okay, let us do one thing. If you do like this, then it's a problem. So copy.
Notepad. Let's open.
Yeah. So we'll go one by one. So first one is parenthesis. 10. So right.
10 plus
okay.
1.
Plus 1.
Yeah.
Plus
4 divided.
I'll keep it like this for now. Yeah. Minus 2 slash
1 plus 3
plus
9.
3.
Yeah. Okay.
So, no, we'll keep it like this. Yeah. We'll do step by step. Then only it will be 4 slash 2 minus 2 slash 1 plus 9. Okay. Now we have to go for the division part. Okay, division from left to right.
Left to right, okay.
Plus, now you tell me what will be this?
This should be
2,
2, yes.
I'm expecting exact answer.
Yeah, 2, I think 2. But this is This is not any floating
Mm-hmm.
point, is it? 4
No,
point
true division
4.
will give like that only. So just 1 second.
4
4
divided.
slash. Okay, it will give always in floating point. So if you want like then you go for floor division in that case.
So okay.
Okay.
So division, this will always give floating, is it? And that one
Yes,
will
yes.
give only if one is floating.
Yes, correct. Yeah.
Okay.
Might
Okay.
be I did not cover this example. Yeah. So by 2 will give 2.0.
Okay.
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 So minus then 2 slash 1. So it will be
Remainder, right?
no. This also division.
This is okay.
2 only. So 2 by 1, 2. But
Double slash
yeah,
is
so
also division.
double slash is also division. No? That's what we have just seen.
Okay. Okay.
Floor division.
Okay.
But what is the advantage with floor division? If both are integers, it will give integer.
Okay.
Like you expected. Like you expect.
Yeah.
Okay.
Yeah. Yeah.
So, yeah,
Sure.
if one of them is float, then only it will go for float.
Okay.
But anyhow, that float value will be incorrect.
Okay.
Okay. So it is better whenever you are expecting the result to be float, it's better to use a true division.
Okay.
Normal. But when you are expecting like you expect that all your numbers will be integers and output will also be proper integer, then you have to use the floor division.
Okay. Plus 9.
Plus 9. Yeah. So now again, it is from left to right. But now
Then
everything has to be
addition.
converted to common type. So you are getting it right. So we have to convert everything to the common type.
Why?
Something like this. Because any arithmetic operation
Requires same
yes.
data type. Okay.
Yeah.
Okay.
The numbers must be numbers converted to common type.
So
Then we
basically,
will
you
do the
cannot
addition or subtraction.
even add integer and floating. That's not allowed.
No, ideally, finally, you can give the output in only one data type.
Okay. Okay.
So that is the reason they will be converted to common type, and out of integer and float is given the precedence.
Okay. Then
So in that case,
11
2.0 minus 2.0 plus 9.0. So now it's exactly 11.0 plus 2.
13
13.0 minus
minus
2.0
2.
plus 9.0. So it is exactly, if I'm going from left to right, it should be like this.
Yeah.
So 20. I'm expecting this should be the output.
But if addition, yeah. Left to right, is it? And
Left to right. Everything from left to right.
okay.
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 So this should be our final output.
Okay.
Okay. And next, but when there is one exception for this.
Okay.
Okay. Exception is exponentiation.
Okay.
Okay. For exponentiation, the order of evaluation is from right to left. What does that mean is when you come across two exponentiation operators together, maybe like this.
Okay.
Okay. So generally we do, since both have same priority, right? So we generally go from left to right.
Right.
Okay. But in exponentiation, it is from right to left. Okay. So I have to evaluate this as, there is no good
9
reason
raised
for
to
this.
power 281.
Yeah. So here, 2 star 8. Yeah, 3 cube 81, right?
Yeah.
3 cube 81.
Okay, 3 cube
much bigger.
81, yeah. 81 and
okay.
then, yeah.
Yeah, so this much
one.
bigger number, we don't calculate. Okay, so it is calculating. So this will be the output. Whereas the other case, if you have thought the earlier case, then it would have been different one. Okay. So this is the difference, and in my case, as I was saying, you do have some notebook stuff. Okay.
Mm-hmm.
So in this, I'll be asking. There are no outputs. Okay, but you can guess the output. So if you want, you can do now, or if you want, I can share the notebook also. You can try by yourself.
Yeah, you can share. I will try.
Okay. Yeah.
Yeah, sure.
So this is we have covered next. Okay, and there are two programs. So I just took something like simple example.
Mm-hmm.
So if I give you a value like speed, okay, in meters per second, I want you to return the output in kilometers per hour.
Okay.
Okay, can you quickly tell me now what will be the program?
Okay, meter divided by 1000.
Maximum 5 minutes.
I mean, kilometer.
First, go to Google, search meters per second to kilometers per hour, how you will convert. Then apply the arithmetic operation. Done.
100, like it 1 kilometer is 100,000 meter, right? So, and 1 hour is
Yeah,
60,
like that. Yeah,
right?
you can
So,
take this. Correct.
yeah, 1000 divided by 60, like this.
Yeah.
And
Yeah. So expectation is any value I give, you should give me the kilometers per hour value. So I'll give you the meters per second value, and your program should return me the kilometers per hour.
should I write this program? So you 1000 and second into 60, 100 meter per second. And it 100 into 1000 divided by 60, like this. Just a second, I haven't tested it. I think like this. If you going.
Yeah, you ping me in chat. I'll put it here.
Sure. I mean, mostly like this, right? It will work.
Yeah, but I'm asking you to take the input from here.
Yeah, just a second. You can do like this. S1 equal to input, and then you can simply say enter. Okay.
Okay, no problem. I think 5 minutes over.
Yeah.
So your logic is correct. So let us just see.
Yeah.
So I took it like this. So int of 600 by 1000. So that is perfectly fine. So then you will get the output in that kilometers per hour. Okay.
Yeah.
And then this is another expression. Now we have done together.
Yes.
So now you will do it by yourself. Okay. Okay, I'm showing. So whatever output you give, when we execute, we should get the same output. I mean, you should not execute the code, but only tell the output for this.
This one, is it? Okay.
Yes.
This is 201 and
I made it complicated.
And
this.
2, 4.
Just 1 second. Just 1 second. I'm giving you the correct one. Actually, the one which I gave you is not so correct because it is taking the formatting incorrect. So this is simple. Actually, I give simple only. It looks complicated than what I thought. So this is just do it in Notepad only.
Yeah. Just give me a
Copy
minute.
and do it.
Yeah, sure. Just give me a minute. I will try. So this should be 1 3 to here. Then it should be
Yeah, you can use calculator, anything, but we are only checking the order of precedence.
this is then expression. Okay, left to okay. So then it should be 200 and 3 3 is 9 and 3 this one 2 2 is 4 8 and 16. So it should be 16. Then division and multiplication 300 is first. This percentage to what's that like? It was modular,
Modulo,
right?
modulo.
Yeah. And multiplication is same, is it?
Yeah, multiplication, division, modulo, all three are same.
Multiplication, division, modulo. No, according to PEMDAS, is it? Multiplication.
Yes, PEMDAS only.
Yeah.
Parenthesis, exponentiation, multiplication, division, addition, subtraction. Actually, multiplication, division is actually together with modulo. I mean, we don't take it as separate.
Okay.
So here, that's why I just put this exact one. Is that? Yeah, you can take this one reference.
Division, it comes like this, and 12 divided by 16. Yeah, I think it will take.
Your mind should register these things within this.
Yeah.
Okay. Yeah. So no problem. Or else you can try it later also.
Yeah.
Or we can do it together once, which since I have it already. Okay. So here, first is I have written like how I have done also. So this is the approach. So first I am going with the parenthesis.
Yeah.
Step 1, 201, and here 81 by 3. This is 27. I removed the inner parenthesis. So I have to come from inner to outer.
Correct. Yeah.
So I am still in the parenthesis step only, 27 by 3 into 100. So next, again in the parenthesis step, I removed this parenthesis. And here, 27 by 3, I took as 9.
Yeah.
9 into 100, 900. Okay. Ideally, I should have kept it here floating, but yeah, it's okay. So again, parenthesis. I removed that parenthesis. Okay, now I am out of all the parentheses. Now I'll start with the next one, exponentiation.
Yeah.
So exponentiation, 2 power, that modulo. So in this, I have to evaluate from left to right.
So 12 divided by 16. Minus, actually, I stopped at this point.
Yeah.
So you first have to take this modulo, right? 100 or modulo 2.
Not modulo. Multiplication, division, or modulo, anything. Actually, here R I am saying is modulo. R is remainder. R means modulo, I mean to say. Yeah.
So a modulo comes first before division, is it?
Nothing. I told you, it is same. See, here how I mentioned the order, you see. Parenthesis first. Okay, then I gave one arrow. Then exponentiation, then another arrow. Multiplication or division or modulo. All three are same.
All three are same. I mean, if we do left it like right. This, left to right. So
yes. No. Equal,
right? So equal. So if you go there, okay, go back, and if we take modulo first, because we can take anything, right? So 100 modulo 2.
No. Equal, but left to right.
Equal, but left to right. But if we say, okay, so you mean to say in this?
Yeah, whenever, see, the confusion comes when some things are equal, right?
Yeah. Yeah.
Okay, but Python's way is when all are equal, it will go from left to right. That is called associativity. So that is why we define one point mentioning that if operators have same precedence, then the order of evaluation is from left to right.
Ah, okay. That's where actually I stuck. I was
Yeah.
saying
Yeah, no
modulo 2.
problem.
I took
Yeah, so
this
those are the
first.
important points.
Yeah.
That's good one.
Yeah.
So here, so 100, so I have to first go from left to right. I'm going purely, so here, where is this? Yeah, so left to right. So first one, this one, 12. 3 into 4, 12.
12.
Okay.
Divided
So I
by
kept rest
4.
all things same, that's why.
Yeah.
Okay. Next, 12 by 16.
Yeah.
0.75. Next,
Okay.
rest all same. Next, 0.75 for floor division 100.
100. 0.
Okay. So one of them is float. So I'll get in float only and rounded off towards 0. Because ideally it will round off and I'll not get the exact floating point value because it is floor division.
Okay.
Okay. So I'm getting 0.0, then percentage 2 plus 900 as it is. 0.0 percentage 2. This is again 0.0 only.
Yeah.
Okay. Plus 900. Now again, see, now at this point, now again I have subtraction addition. Both have exactly same priority.
Okay.
Okay, but still the associativity is from left to right.
Okay.
So I have to go like that only. So minus 0 plus 900. So first this one minus 0. So I'll take that. So that is 201 plus 900.
So that
then
is
the final output should be like
okay.
this.
Okay.
Okay.
Got it now. Okay.
Okay. And since you are asking like sometimes like what is the real use case, right? Something like this. So I have one thing for bitwise operators. Okay, I'll come to this when we complete the bitwise.
Okay.
Okay. So these notebooks, what I'll do is I'll create one folder from now onwards. Within that folder, I'll create another folder called notebooks. In that, I'll put all these notebooks. Okay, you can take.
Okay.
Yeah, if you just have Jupyter notebook, it will be very good because these are from my earlier classes. So where I was writing some comments and as well as giving bit of clear description within the notebook itself. Okay.
Okay. Yeah. I will try Jupyter.
Jupyter lab, then done. Okay. So it will install.
Okay.
So arithmetic are done. Next is comparison operators. Okay. So we have totally 8 comparison operators in Python. So comparison means compare one value with the other. Okay. So they all have the same priority, which is higher than that of Boolean. Calling the earlier operators all as arithmetic. So we call all this as a comparison. Okay. So in this we have less than or equal to. So all these conditional checks. Yeah. Whether it is equal to, not equal, yes. is not. So like. Yeah. So, okay, we'll come to chaining comparisons after a Boolean, but only comparison operators if we check, simple, less than means if the left side is less than the right side operand, okay, left operand is less than the right operand, then it will return true. Else false. Okay. Like normal case only, normal math, everything in normal mathematical case. Correct. So, 5 greater, so always the result will be in Boolean data type. Yeah. Okay. 5 less than 2, like this. Okay. 5 greater than or equal to 5, less than or equal to 5. So, like this. Okay. So normal mathematical, how you think, based on that only you'll get the output. Okay. Okay. If it is a true thing, true statement, and then it will give true, or else it will say false. Okay. And like 3 things to store for object. One is object's value. Okay. And another one is the object's type. And third one is the object's ID. Okay. So ID means there is like something called ID function. Okay. So now in this case, value is something which really say like 5 dot value I cannot say. I cannot access it, but I can understand that object 5 means it has a value 5. Okay. So when Python compares, it will compare either as an object or as a value. 2 ways of comparison are possible. Okay. So what is the difference is when I'm saying 5 is 5. Okay. Then it will compare like an object. Okay. In that case, what it will think is So here when I'm writing 5 and 5. Okay. So in the memory, let us think that this 5 is located here, this 5 is located here. Okay. If you think that Python is having two different 5s at two different locations, then these are not the same object.
Okay.
Okay. So it should have 5 only at one place. So, okay. So whatever I say 5 and 5 again, the object is still the same. Then it will say true. Means we can take another more better example, like if we take in terms of variables. If I say A is equal to 5, B is equal to 5. Okay. So A is B. That is true. Because now A and B are ideally pointing both to the same object.
5. But tell me one thing. You said let's say A is pointing to 5, B is pointing to 5. But then you say 5 is one location, 5 is another location. How do you say one location, another location? Both are 5.
No, I just gave like example kind of. That's it. So I'm just saying like if they are in different locations, then we cannot say they are the same object.
We cannot know the location, is it? We can only know the value. How do we know?
No, we can. We can say by calling one ID function.
Okay.
ID of A. Okay.
Okay.
ID of B. See, this will give a memory address.
Okay.
Okay, this is for the C Python implementation. But ideally, we are using C Python only.
Okay.
So ID will give you the information about this, whether they are in the same place or not.
Okay.
Okay. And in fact, when you are using the is operator, okay, is will compare the IDs only.
Okay, he is comparing the
so
IDs.
Both IDs are matching, then only it will say okay. If not gone, it will not say yes.
Okay.
Okay. So now same thing. A equal to B. This will also be true because the values are also 5 only.
Yeah.
Now here it's comparing the value, not the memory location, the value. The value as a mathematical thing. Okay, whether 5 is 5, value is same. Okay, so another example for more clarity, say A is equal to 5, B is equal to 5 dot ID of A, ID of B. See, now they are in different locations. Okay, so now if I am saying A is B, false. Then you'll get false.
Okay.
But if I say A equal to B, you see what is the output. It is true. Mathematically, the value is same only. Okay, whether I say 5 dot value comparison, double equal to will do the value comparison, but is operator will do the object comparison, whether they are the same object or not.
What do you mean by value comparison?
Value means just the value in mathematical sense.
Okay.
5 and 5.0 same values,
same
right?
thing. That's why it's
the way I'm writing is different.
Okay, but if we checking with equal sign, let's say, or is sign, right? Then it expects at the same memory location.
Yes, when I'm writing with is operator.
Is operator. And if we just say A equal to 5, A equal to B?
A equal to B, yeah. This one.
Yeah.
This is assignment. See what will happen with this.
Oh.
Now, actually, when you are saying A is equal to B,
okay.
Earlier A was having
value.
Yeah,
of
A was
A
having
to B.
5. Yeah, now A is also pointing to 5.0. It will forget about 5.
Oh, okay.
This is assignment. This is comparison.
Okay.
So I mean, this is very key difference between single equal to double equal to.
Okay.
So double equal to only returns a Boolean data, like return value. Assignment will not return anything for you.
Right.
It will just do an operation that A will also now point to
B
5.0.
Yeah.
That's it. A will also point to B's value.
Yes.
Okay. So all comparison operators will definitely return a Boolean result for you. So you can check by that one. Okay. So is operator, X is Y is true if and only if X and Y are the same object. Okay. An object's identity will be determined by the ID function. Okay. X is not Y yields the inverse truth value. I mean, we are checking like opposite thing. So now in this case, A and B are.
Okay.
So I'm asking like A and B are not the same objects.
Yeah.
Then it is saying false. Because they are the same object.
Okay.
It will be mainly compare only the values of two objects, unlike the is and not is. We check whether two objects are exactly the same, meaning they refer to the same object.
Okay.
Next. So whatever we came across, numbers of built-in numeric types and of the standard library. I mean, there are also fractions, decimal, those things. They can be compared within and across their types. So such kind of possibility is there. Why I'm saying within and across means, when I'm saying A is equal to 5, B is equal to 5, C is equal to 5.0. Okay. So the comparison of values is possible within and across. So means within means A equal to B.
Yeah.
Okay. Across means A, we are crossing from one type to another, but A and B are same type. So that is also possible. This is also possible for numerics.
Okay.
Okay, numeric types. I mean, especially numeric types only. So within the limits of the two types involved, they compare mathematically correct without loss of precision. I mean, it will not make like something strange. So A is equal to, I am saying 5, and C is, I mean, it will see that mathematical validity should be there. It's not support any order comparison. So A is equal to 3 plus 4j, B is equal to 3 plus 2j. So then, whenever we are saying order comparison means whether we can order them in a line or not.
Do we use complex number somewhere?
No, just for your information. At least I did not use any time. Might be I have to go to that specific domain where they are used, then only it will be useful.
Okay.
Yeah. Okay. But one point here is order equal to 5, B is equal to 2. I am saying A greater than 5 means then I am doing an order comparison. Means which one comes first, which one comes next. Means in this case, 2 will come first, 5 will come next, right? So it is like it is an order comparison. But when I'm saying A equal to 5, then it is an equality comparison.
No,
just for understanding of terms. I mean, if at all you refer to Python, then it will be written like this only. Okay. So all greater than, less than, or equal to, all these are order comparisons. Means they will sort the numbers. I mean, they have the capability to tell what is the order. Because if you are saying greater than is false, then you have to put something before and something after. So like that you can understand. You can make an order. So that is called order comparison.
I don't get this order. Can you come with some better example? I don't understand. I mean, what do you mean by order? Let's say A is greater than 5. So A equal to 5, that's why it's not greater than 5. What is order in this?
Okay, no. Order comparison means I'll tell you. For example, if I am saying A is equal to 1, 2, 3.
Okay.
Okay. We are simply writing max of A, right?
Mm-hmm.
Max function. It will give what?
Maximum of all the 3 elements, right?
3, yeah. 3. If it has to give 3, what it has to do? It has to check many things. What it has to check?
It has to
First, it might assume that 1 is the maximum number.
Okay.
Then it will check 1 is greater than 2 or not.
Okay.
Okay. If that condition is failing,
yeah,
then 2 will become the maximum number. Then it might check 2 is greater than 3 or not. If that condition is failing, then 3 is the maximum number. So to get to the maximum number, so what it will do? This order comparison means which one come first, which one come next. So it can make an order. So what will be the final order for it? Something like this. So based on that, it can say 3 is the maximum value. So sorting or ordering you can do. Okay. But that is possible only with which operators? Comparison operators. So I mean, they are called order comparison.
Okay.
So whenever I'm comparison can be comparison for an equality, and also comparison for an order. Because finally you'll make them in like ascending or descending, and then say descending means the top one is a maximum value. If you say ascending, the first one is a minimum value. So you make an order, right? Then only you can conclude.
So basically, when we give this comparison operator, behind the scene it arranges descending and do all this order sort of thing.
No. For single operator it will not do, but this is what I mean to say is this category is order comparison. That's it. Don't think much. So less than, greater than, all these are order comparison operators.
Okay.
That's it.
Okay.
And other categories, equality comparison.
Okay.
Equality comparison means double equal, not equal. That's it. Okay.
Okay.
So just, I mean, because the term has come, I am just explaining.
Okay.
Complex numbers will not support such kind of things. I mean, you cannot sort a complex number.
Yeah.
Because they don't support any comparison, right, between one and another.
Yes.
Okay. They can only support equality comparison.
Okay.
Means you cannot put complex numbers in one order. So we cannot say 3 plus 2j, 3 plus 4j. So that's what they mean to say. We cannot order them in fashion. So we cannot we can only compare the equality.
Okay.
And in fact, in number line also, we cannot draw any complex numbers, right? So saying this comes first, this comes next. Next, strings. Strings compare lexicographically using the numerical Unicode code points. Hello, greater than I. Okay, it is saying false. So how it will say? First H and H. Both comes first. So based on that, so it is giving the false. So how I will compare? So there is one built-in function for this. So for this, you can give this one and this one. So it will give those ASCII values. ORD function.
So it can compare the string as well, and that too in the from left to right, matching each string and then saying it's good.
Yeah, but I mean, see, if you just see from alphabetical point of view, you say that ABCD comes in this order and you do the comparison. But to be more precise, we can say that it compares this ORD values.
Okay.
Okay. So based on that, it can give which one is comes first. Okay. So 101 is definitely not greater than 105. So it will return a false. Okay. So it is based on the second character in this case.
Basically, anything it should get first, that's where it says it's validates on it, because E and I, E is smaller.
Yeah, it's not based on the order, but it's based on the value actually. Okay. So I is having a greater ASCII value, so it is taking I as the maximum one, okay, not the hello.
Okay.
So I greater than.
Okay. If it was, suppose it was HA instead of high, then it would have returned true, is it? No, just keep it like that only. Hello, and that side high instead of high HA.
Okay.
Then it would have said true.
Then it is correct.
Because
now that's why you don't go with the order of the ABCD like that. You don't go. You go with the ordinal value, ORD value, the ASCII value.
Okay, but tell me one thing. So it compares only the smaller string length, let's say, because it only has 2 in the right side length. That's why it compares only 2 of them.
No, yeah, only 2, correct. That is correct. So only 2, that is a possibility, right? So there is no other possibility. So you can take like this also. Okay. So whatever is some
and then it ignores LLO
to the minimum
altogether. So it's completely ignoring the bigger string. It
yes,
does
correct.
Not
this is ignored. Yeah.
Okay.
And yeah, what sequences can be compared.
Lexicological,
lexicographically.
What is this?
So this is actually should be based on this alphabetical stuff only. So you can dictionaries. Okay, that's what these people say. Alphabetical order they are saying. But the thing is, though in the alphabetical order, the latest one is being considered as a greater one.
Okay.
That is the thing. So E is considered greater than A as per the alphabetical ordering also.
So that's why. Okay, that's called lexicographically.
Yeah.
Oh man.
And so I mean, I wanted to give a view different things we can compare, not just numbers. So next is strings, and then sequences, list, tuples. Only the thing is the ranges do not support again order comparison. Okay, so equality comparison is possible for all of them. So for example, how we have to take sequences? So here I can take L1 is equal to 1, 2, 3. L2 is equal to 1, 2, 4. Okay. So now I am saying L1 greater than L2. So it has to compare value by value. Okay. So 1 greater than 1.
So it will compare positional values.
Yeah, positional values, correct.
Okay.
3 is not greater than 4. So it will give the false. Okay. So if it is equal, there is nothing to say. But since we are checking for the greater than 1, so last value will be considered. So the 3 greater than 4 will return the false. So whenever you are giving sequence, so it is a value by value. So again, shorter sequence means compare only up to that point.
Can you compare 3 1 1 in place first one? Can you go back? If we say L1 is 3 1 1, then
equal to 3 1 1 na?
Yeah, 3 1
Sorry,
1.
1 like this, right?
Correct. So because the first one is greater than, then it directly give true, or because rest two are small.
Yeah.
So the very
3
first
greater
one.
than.
So it looks for from left. It looks for the first position to be
First,
greater,
yeah.
and then it doesn't compare further.
No, actually, just a second. It should not be like that. For two collections to compare equal, they must be of the same type, same length. Each pair must be equal. Okay. That support order comparison are ordered the same as the first unequal elements. Correct. First unequal elements.
Yeah.
So here the first unequal elements are coming at first place only.
Okay.
So that is why 3 greater than 1 is true. Then it's fine.
So first only, and then it stops. Doesn't count anymore.
Then it stops. Correct.
Okay.
So that is the first unequal. So we can make it like L1 is equal to 1, 3, 1. So that should also L1.
Okay.
Yes, the corresponding element does not exist. Shorter collection is ordered first. So yeah, if it is missing, so it is saying shorter collection. So 1, 2. So less than 1, 2,
it says
3.
Equal length. Yeah. It says equal length, right? So
no, there are two cases. Okay. One is if you want them to be equal, okay, then they should have same type, same length, same elements.
Okay.
That is first case. Second case is when the elements are different, like unequal elements. So whenever we have unequal elements, like here, x and y are unequal, let us think. 1, 2 are same, but x and y are unequal. Length is same again. Third case, lengths are different. Okay. In this case, the shorter sequence is ordered first. So means in the ascending manner. So this is considered bigger than this one.
Yeah. Okay.
In this case, yeah.
We can still compare.
So just okay. But for strings, it is not the same, I believe, because this is mentioning especially for the sequences.
Yeah.
And not for the strings. Okay, it is here. There's nothing mention of such kind of description. So let us take strings hello.
Is greater than HE.
Yeah. So this is true. Yeah. In this case, yeah, shorter sequence is considered correct. So again, shorter sequence is smaller compared to the bigger sequence. Same thing you can apply here also.
Okay.
But if it comes the first, it is able to find the first unequal elements, then the result is changing.
Okay. Yeah. Then the result is changing. It stops further than that first greater. Okay.
And next, mappings means dictionaries. So they will compare equal if and only if they have equal key value pairs. Order comparison is not possible. Only equality we can do. So here 1, 2, 1, 8. So D equal to D1. So it is true. But we cannot do like this. Okay. So it will raise a type error. Okay. For this data, whenever you are seeing type error anytime, you can remember that it is talking only about the data type. For that particular data type, that operation is not supported.
Okay.
And sets can be compared within and across their types. Okay. So like across their types means we have only two types. One is set and other one is frozen set. Okay. They define order comparison operators to mean subset and superset tests. I mean, only these relations do not define the total ordering. Like we can take 1, 2 and 2, 3 are not equal nor subsets of one another. Okay. So it cannot give like every possible combination, but it can do something like 1, 2. So S2 is equal to 1, 1, 2, 3. Okay, so S1 less than S2. So that is true because one is a subset of the other one.
Okay.
S2 greater than S1. That is true because S2 is a superset of the S1.
Okay.
Okay. But if we are taking some odd case, like if I am saying something like this, okay, S2 is equal to 3, then S1 greater than S2. False. So here, why it is saying false? Okay, there's do not define total already.
Because
Are
one
not
is
equal,
smaller
not
than
subsets.
2. One is smaller than 2. That's why it's false.
Yeah, but ideally it is not defined like this. Do not define total ordering. So they are not equal. Yes, they are not subsets of one another, not supersets of one another. Okay. Sets are not appropriate arguments for functions which depend on total ordering. Okay, so anyhow, these are not appropriate arguments for the max function. So let us take max of S1. Okay, it's
If it takes max, then S2 should be greater because max 1 would be 3.
Max of S2, if I am applying, yes, then it is 3 is greater.
Yeah.
But so here my doubt is only this one. So we do not define total orderings. So 1, 2, and 2, 3 are not equal.
Positional, right? So we cannot take that the first position is smaller or greater like that. How we're doing?
Yeah, that is one case. But why it is returning the result? This is what I am doubting. So it is saying S1 greater than S2 is false.
Yeah.
What comparison it is doing in this case? So that is important. So anyhow, I'll check this. Okay. Because generally sets I don't go that much deep. So this time I thought I'll explore one more. We can do across the sets also. So let us take S2 is equal to frozen set of comma 2. Okay, S1 equal to S2. So that is also possible. Okay. Within the set, across the types. So that is possible. Okay. So only one point is how it will handle this kind of things. So I'll see if we find something. Okay. Next, Boolean operators. Mm-hmm. So Boolean operators are good to know because this will be very much useful in all the if conditions. Okay. Mm-hmm. So A is equal to 2, B is equal to 3. No, let us make not this one. Let me take first this one. True or false? What is the output for this one?
True. Or no, true or false? False?
Think.
One is true and one is false. So should be false, I think. True is true. True, false is false.
See the output.
True or false is true. Oh, true and false. I think false. That's false.
Yeah, correct. True and false is false.
Yeah, true and false. And true or true both are true. Correct. So that one should be true. Correct.
Okay. So here, similar kind of thing we'll be applying here. Okay. So Python is a bit more intelligent, and so it will not do the operation until it requires it to do so. For example, so whenever the first one is true, okay. So we call these operators as short circuit operators. Mm-hmm. Okay. So it only evaluates the second operand if the first one is false in the OR case.
Yeah. Otherwise, it stops at the very first.
Yes. Correct. Because one is true means we don't bother about the others. Because it is OR condition, right? We don't bother about the other stuff.
Yes.
So that is why false or true. Then it will be first one is false, so it will still check the others. Yeah. So the second one is true, so that is the output. Okay. So if I am saying false or false or true, then true. Still give the true last one. Yeah. Okay. So and is also short circuit operator. It evaluates the second argument if the first one is true. Okay. So if I am saying false and true, what will be the output for this?
False.
And in this case, what Python will do is, if first one is false, it will not even check whether the second one is false or not.
Yeah. It will just see first.
It will not worry about the second one itself.
Yeah. False.
Second, third, or 100th one, it will not worry about that.
Okay.
Not X, just opposite. So not true, like this. Sorry, not space. It will.
Okay.
Now,
there is a difference between capital TRUE and small TRUE, is
it? Capital TRUE is the keyword.
Okay.
Python is case sensitive.
Okay.
If you are writing small true, then it is understanding that it is some variable name.
Okay.
So it is saying it's not defined.
Okay. Case sensitive. Okay.
Yeah. We will be applying the same thing to numbers.
Okay.
So now I have a question for you. So 0 and 4. What is the output for this?
0 and 4. False and 0.
Perfect, 0 only, because 0 is considered as a false value.
Correct. And anything apart from false is
anything rest we will not bother. So and it will give the output in terms of the actual arguments only. Only the consideration is like you have to consider it as false and true case. Okay. And now 4 or 0. What is the output for this? Okay. Then non-Boolean operators. For example, if you have, sometimes you might come across situations like this. Not of A equal to B. So in that case, which one we should evaluate? So in that case, you should evaluate the A equal to B first, and then the not on top of that. Okay. So if I am mentioning A equal to not B, then it is a syntax error. Okay. So this is not possible. So in this case, it cannot. It says it cannot do that comparison which comes first, which comes next, all those things. Okay. So this is not at all allowed also. Okay. Unary arithmetic. Unary operators means which will operate on only one operand or one argument. Okay. So simple example, minus plus. So actually minus is also considered an operator. So A is equal to 2, minus A means minus 2, like this. So minus is being applied onto 2, but 2 is a single value. We are not applying on more than one value. So these are all unary operators which we are applying on single value, minus, plus, whichever we consider. Okay. And next is unary bitwise unary inversion operator. So for example, A. So this is minus 3. So for
how?
That is a big story actually. So you have to take a 2's complement, then only it will come. So you have to take all the bits. Okay. So 1, 0. So in this case is equal to, so maybe 1, 0 I'll keep here. Then I have to first B. So now I have to find negation of A. Actually, negation of A means we have to invert the bits. Okay. But ideally, if I invert the bits, so then it should come 1. Okay. But my output is, what is that? Minus 3.
Yeah.
Right. So, yeah. So minus 3. For this, actually, we need to understand 2's complement. You know 1's complement, 2's complement?
No. I mean, do we use this inversion? I mean, what is this?
Okay, so that is why I'm thinking we'll keep this one for the last.
Okay.
Because it will take at least some 20 minutes time minimum.
Yeah.
Okay, and whether we will use it much or not. But one simple logic, what I'll tell you is, what these people have done is to make the things simple. They are using the 2's complement form. Okay, because what happens for a CPU operations, it will all have 1s and 0s, right? 1, 0, 1, 0, all this stuff. So they always wanted to do only addition.
Okay.
So 1 plus 0 plus thing only between two things.
Okay.
Even if you give 3 minus 2, they will do only addition.
Okay. 3 plus
Why?
minus 2.
Minus 2, they will make it as some other bits.
Okay.
3, they will make the bit format. So then they will add both.
Okay.
Because for this arithmetic and logical unit in your computer, so for this it will be easy.
Okay.
To do the addition of the bits. Okay. But minus numbers, how we can store in system? So for that minus numbers, they actually implemented 2's complement form.
Okay.
2's complement means they will just make a original number is 1 0. First they will invert the bits 0 1. Then they will add one bit. So like this 0 1. So like this. So for 2's actually for 2, I mean the 2's complement is again the same.
I mean,
so
what is
but
the
still it will
practical
work.
application of this? What is the practical application?
No. This is something for internal for your computer.
Okay.
Because see, for the computer, it doesn't. I mean, they don't want the hardware to. I mean, hardware to perform this. The hardware should perform ones plus zeros. That's it.
Okay.
Okay. So for minus numbers, what they will do? So they will convert that minus number into another set of ones and zeros because they cannot use the same like original number.
Yeah.
So because 2 minus 2 should give always what?
0.
0.
Yeah.
Okay. So they should convert this minus 2 into such a form that 2 plus of minus that 2 form should give 0 only for me.
Yeah.
Okay. So 2 is in binary format 1 0.
Okay.
Okay. Ideally minus 2 also the 2's complement that is also 1 0. But what will happen if I add this 0 0, this 1 bit will be discarded. So output will be 0, something like this.
Right.
Okay, so at the end they want to convert that negative number into a bits ones and zeros. Okay, and add it to the positive number. So that result should always be 0 whenever we are like doing the subtraction of the two numbers, the equal numbers.
Okay.
So this logic will work for all the negative numbers. So all the negative numbers, if you make a 2's complement, then add it to the positive number, then you will get the expected result. Okay.
I was just understanding what is this invert operator? Is it used? Where is it used? Bitwise inversion or?
Yeah, I did not use, but yes, definitely it might be useful. Use case. I mean, in mine is network testing. I did not put any time this invert operator there.
I mean,
but invert operator I cannot say, but we will be using bitwise operators. There are also other operators.
Okay.
Okay, like ampersand and or type symbol.
Okay.
They are also bitwise operators, but they don't have this complexity of understanding 2's complement. They will only apply the AND operation on bits.
Okay.
Okay, and that is very much useful in data analysis. Okay. So there we have the application of the bitwise operators. Okay, but invert operator as such, I did not find any application. Okay.
Yeah.
Okay. That's why I'm taking this as second priority, because see, if we are completing in fast and we still want to do something, then we'll see. Okay. But we have to remember that simple thing.
Yeah.
If you are inverting something, then you will not get as expected. The output will be like this. This is a formula you can think. So it will be minus of x plus 1. Okay. When you see the decimal output. So negation 2 will be minus 3. Negation 4 will be minus 5 like this. Okay. So this you have to remember. Okay, I think with this we will stop and tomorrow we can continue with binary bitwise, shift operators and operator precedence will complete. So with that operators will complete, and mostly tomorrow we'll start another topic also, the if statements.
I was saying, can we continue on Monday instead? I think there's a lot already converted. I couldn't revise and couldn't perform.
Tuesday.
Yeah, actually, it's like I should practice as well, because too many things have already been completed, right?
That is actually very much important. Yeah. You have to practice and make it. I mean, you have to capitalize on it at the same time.
Correct. That's why
Yeah,
I
if
was
you are
saying.
not practicing and we are just continuing the classes, that will anyhow be not be useful. With that, I am flexible. I'll just postpone it if you want, and we can take some 2 days gap, and again you want to revise, and then start the next set of sessions. That is also fine. Because see, if you are learning and asking questions, that will give me more knowledge also.
Yeah, correct.
If you're just sitting and maybe last class you did not revise, and that will not help you or me also.
Correct. That's what
Okay. Yeah,
actually
no problem. So
too many
tomorrow,
exercises are also
tomorrow's thing I'll
mandatory.
remove.
Yeah, tomorrow you just
And
schedule on Monday and then we continue from there.
yeah, Monday and Tuesday. Still 2 more classes are left as per our initial plan.
Correct.
So
Then
Monday and
I
Tuesday
can
I'll
you can raise the invoice and I can do it again.
Yeah, after Tuesday, I mean on Tuesday we will check together.